Welcome to Sleepless Philosophers, where deep ideas meet restful nights. If you enjoy these journeys through philosophy, please like and subscribe and turn on notifications for daily uploads. To support the channel, consider leaving a super thanks. Any amount helps us continue creating content. You can also become a member to request video topics. We're not monetized, so your support truly makes the difference. Now let the philosophy begin. Schrödinger's cat, the pet that's both alive and dead. A cat sits in a sealed box, a box that cannot be opened or observed from the outside. And inside the box with the cat is a device, a quantum mechanism that has a 50% chance of killing the cat within 1 hour and a 50% chance of leaving the cat alive. Perhaps a vial of poison that will break if a single radioactive atom decays. And the decay is a quantum event. Genuinely random, with no way to predict whether it will happen in the next hour. And so after 1 hour has passed, the cat is either alive or dead. 50-50 odds. And this seems straightforward, but the paradox emerges when quantum mechanics is taken seriously, when the rules of quantum theory are applied consistently, because quantum mechanics says that before a measurement is made, before the box is opened and the cat is observed, the system exists in a superposition, a combination of both possible states simultaneously. And so the cat is both alive and dead at the same time, existing in a strange limbo where neither state is definite until observation collapses. The superposition and forces the system into one state or the other. And this is Schrödinger's cat, a thought experiment devised by physicist Erwin Schrödinger in 1935 to illustrate what he saw as the absurdity of applying quantum mechanics to macroscopic objects to show that something was wrong with the standard interpretation of quantum theory. Imagine the situation step by step. At the beginning, the cat is alive, the radioactive atom has not yet decayed, and the quantum state is well defined. But as time passes, the atom enters a superposition of decayed and not decayed, because quantum mechanics describes it with a wave function that assigns amplitudes to both possibilities, and these amplitudes evolve smoothly, and the atom is in a state of quantum indeterminacy, neither definitely decayed nor definitely not decayed until a measurement is made. And this indeterminacy is not ignorance, not a matter of the atom being in one state or the other, and we just do not know which, but a genuine feature of quantum reality. The atom literally does not have a definite state until measured. And because the poison release is coupled to the atom's state, the poison is both released and not released. And the cat is both dead and alive, existing in a superposition of macroscopic states. And this conclusion seems absurd, seems to violate everything we know about cats and boxes and life and death. And Schrödinger intended it to be absurd, to show that something must be wrong with the orthodox interpretation of quantum mechanics, that the theory cannot be applied consistently to large objects, that there must be a boundary somewhere between the quantum realm where superpositions occur and the classical realm where objects have definite states. The paradox has generated an enormous amount of discussion and debate in physics and philosophy, with different interpretations of quantum mechanics offering different resolutions. The Copenhagen interpretation, the dominant view in Schrödinger's time, says that the wave function collapses upon measurement, that the act of observation forces the system into one definite state. And so when the box is opened and the cat is observed, the superposition collapses and the cat becomes definitely alive or definitely dead. But this raises questions about what counts as a measurement, about what constitutes an observer, about whether consciousness is required to collapse the wave function, or whether any physical interaction suffices. And these questions remain controversial, and the Copenhagen interpretation does not provide clear answers, does not specify where the quantum classical boundary lies. The many worlds interpretation offers a different resolution, saying that the wave function never collapses, that both outcomes occur, that the universe splits into two branches, one where the cat is alive and one where the cat is dead, and both branches are equally real. And the observer also splits, becoming two versions, one observing a live cat and one observing a dead cat. And each version believes they have observed a definite outcome. But from a global perspective, both outcomes happen. And the superposition is resolved not by collapse but by branching. And this interpretation avoids the measurement problem, avoids the need to specify what counts as a measurement. But it introduces other difficulties: the proliferation of parallel worlds, the question of what it means for both outcomes to be real, and whether this is a genuine solution or merely a reformulation of the problem. Decoherence theory provides another perspective, focusing on the interaction between the quantum system and its environment, and it shows that macroscopic objects like cats are constantly interacting with their surroundings, with air molecules, with photons, with thermal radiation, and these interactions cause the quantum coherence, the delicate phase relationships that allow superpositions to be destroyed very rapidly in a fraction of a second for macroscopic objects. And once coherence is lost, the system behaves classically, appears to be in one definite state, and so the cat never actually exists in a superposition of alive and dead, or exists in such a state for only an immeasurably short time before decoherence converts it to a classical mixture, a probabilistic state where the cat is either alive or dead. We just do not know which until we look. And this dissolves the paradox by denying that macroscopic superpositions persist long enough to be observable. The paradox also raises questions about the role of consciousness in quantum mechanics, about whether an observer must be conscious to collapse the wave function, and some interpretations suggest that consciousness plays a special role, that the cat remains in superposition until a conscious being opens the box and perceives the outcome. And this view has been criticized as mystical, as importing mind into physics in ways that are unnecessary and unhelpful, and most physicists reject it, preferring interpretations that treat measurement as a physical process involving interactions with macroscopic devices not requiring consciousness. But the question remains open, debated, unresolved, and Schrödinger's cat sits at the center of this debate, a symbol of the deep puzzles that quantum mechanics presents. Visualize the box, sealed and opaque, and inside the cat waits, and the quantum device ticks, and the atom hovers in superposition. And according to quantum mechanics, the entire contents of the box, the atom, the device, the poison, the cat, all exist in a superposition of two macroscopically distinct states: alive cat no decay and dead cat decay. And this superposition is described by a wave function that smoothly evolves, and the two branches of the wave function correspond to two different realities. And yet before the box is opened, there is only one box, one cat, one system. And the paradox is that quantum mechanics seems to say the cat is both alive and dead. While common sense says the cat is either alive or dead, we just do not know which, and this clash between quantum formalism and classical intuition is the heart of Schrödinger's cat, a paradox that has no agreed-upon solution, that different interpretations resolve in different ways, and that continues to drive research in the foundations of quantum mechanics, in efforts to understand what measurement means, what quantum states represent, and how the quantum world relates to the classical world we experience. The box sits on the table, the hour passes, and the cat's fate is sealed. Or is it? Or is the cat in limbo, suspended between life and death, waiting for observation to make reality definite? And the paradox endures, not because physicists do not understand quantum mechanics, but because quantum mechanics, understood correctly, leads to conclusions that seem impossible, that violate everyday experience, that force choices between interpretations that are empirically equivalent but conceptually divergent. And Schrödinger's cat remains the most famous illustration of this strangeness, a thought experiment that has entered popular culture, a paradox that symbolizes the weirdness of quantum reality. And the cat, alive and dead, real and hypothetical, continues to haunt physics and philosophy, a permanent reminder that the quantum world is not merely different in degree from the classical world, but different in kind, governed by rules that defy visualization and resist intuitive understanding. And the paradox persists, unresolved in the deepest sense, a puzzle that reveals the limits of human intuition and the challenge of making sense of a theory that works perfectly in practice but remains mysterious in principle. McTaggart's paradox of time, why past, present and future are contradictory. A philosopher named J.M.E. McTaggart constructs an argument attempting to prove that time is unreal, that temporal distinctions are contradictory, that past, present and future cannot coexist, and the argument begins by distinguishing two ways of thinking about time: the A series, which orders events as past, present or future, and the B series, which orders events as earlier than or later than each other. And McTaggart argues that the A series is essential to time, that change requires events to move from future to present to past, that without this passage, without the A series, there is no real time. But the A series is contradictory, generates logical problems, and therefore time is unreal, is an appearance generated by our temporal perspective, but does not correspond to ultimate reality. And this is McTaggart's paradox of time, one of the most famous and most controversial arguments in the philosophy of time, an argument that has shaped all subsequent debates about the nature of time, about whether time is real or illusory, about whether the passage of time is objective or subjective. Imagine time as having two aspects: the A series aspect, where events are classified as past, present or future, where we say the meeting is future, is happening now in the present, was past yesterday, and events change their A series position, move from future to present to past, and this movement is time's passage, is what makes time dynamic. And the B series aspect, where events are ordered as earlier or later, where we say the meeting is later than breakfast and earlier than dinner, and these B series relations are fixed, do not change. The meeting is always later than breakfast, regardless of when we consider it. And McTaggart argues that the A series is essential for real time, that the B series alone is not sufficient, that time requires passage, requires events to change from future to present to past, but the A series is contradictory, and so time is impossible, is unreal. The paradox emerges from the fact that A series properties are contradictory. Every event is past and present and future. The meeting is future before it occurs, is present when it occurs, is past after it occurs. And so the meeting has all three properties, is past and present and future. And these properties are incompatible, cannot all be instantiated by the same event. And so the A series generates contradiction. And the standard response is to say that events have A series properties at different times. The meeting is future at earlier times, present at its time of occurrence, past at later times. And this seems to resolve the contradiction by indexing A series properties to times. But McTaggart argues this does not help, because now we must ask whether the times themselves are past, present, or future. And the same problem recurs. If the time at which the meeting is future is itself past, then the meeting is past and future, and contradiction remains. And indexing to times does not eliminate the contradiction, but only pushes it back. McTaggart argues that the only way to avoid contradiction is to eliminate the A series, to accept that events do not really move from future to present to past. That passage is illusory, that reality consists only of the B series, only of earlier-later relations. But the B series without the A series is not real time, is only a static ordering, lacks the dynamism, lacks the passage that is essential to time. And so time is unreal, is an appearance that our consciousness generates from a fundamentally timeless reality. And McTaggart's position is a form of idealism about time, treats time as mind-dependent, as not part of the ultimate structure of reality. Visualize the paradox as a vicious circle. Events have A series properties, but these properties are contradictory. So we index them to times, but then times have A-series properties, which are contradictory. So we index to second-order times, but these are contradictory, and the regress continues, and the contradiction is never eliminated, only relocated, and McTaggart concludes that the A-series is inherently contradictory, cannot be made coherent, and must be rejected. And with it goes time itself, which requires the A-series for its reality. One response to McTaggart's paradox, the tenseless or B-theory response, accepts McTaggart's argument that the A-series is contradictory, but denies that time requires the A-series, argues that the B-series is sufficient for real time, that earlier-later relations constitute time, and passage is an illusion, is a feature of our temporal perspective, and the universe exists as a four-dimensional block, a block universe where all times are equally real, and past, present, and future are not objective features of reality, but are indexical, are relative to a perspective, and this B-theory has become orthodoxy in philosophy of time, is widely accepted as avoiding McTaggart's paradox while preserving the reality of time. Another response, the tensed or A-theory response, denies that the A-series is contradictory, argues that McTaggart's argument involves a mistake, that A-series properties are not really contradictory because they are indexed to times in a non-problematic way, and the meeting being future at T1 and past at T2 is not contradictory, is just the normal way temporal properties work. And A-theorists argue that passage is real, that the present is objectively real, that the future is open and the past is fixed. And McTaggart's argument fails because it assumes that A-series properties must be simultaneous to be contradictory when they are not simultaneous, are at different times, and this response preserves the A-series, preserves passage, and rejects McTaggart's conclusion that time is unreal. A third response from presentism argues that only the present exists, that past and future are unreal, and so events do not have contradictory A-series properties because only present events exist, and only present properties are real, and the meeting is not simultaneously past, present, and future because only one of these is real at any time. And presentism avoids McTaggart's paradox by radical ontological restriction, by accepting that most of time does not exist, and this preserves the reality of the present, preserves passage, but faces difficulties explaining how truths about past and future can be true if past and future do not exist. McTaggart's paradox has been enormously influential, has shaped all debates about time, has forced philosophers to clarify their positions, to distinguish A theories from B theories, to recognize that different conceptions of time have different metaphysical commitments, and the paradox remains controversial, remains debated, with some accepting McTaggart's conclusion that time is unreal, some accepting that the A series is contradictory, but denying that this makes time unreal, and some denying that the A series is contradictory, and no consensus exists, and the paradox endures as one of the most important arguments in metaphysics, an argument that challenges our ordinary understanding of time, forces recognition that temporal passage, the movement from future through present to past, is philosophically problematic, and whether time is real or illusory remains one of philosophy's deepest questions, and McTaggart's paradox continues to structure the debate, continues to force philosophers to grapple with the nature of time, with whether passage is objective or subjective, with whether reality is a static four-dimensional block or a dynamic unfolding present, and the paradox persists, unsolved and perhaps unsolvable, a permanent challenge to theories of time. Meinong's paradox, where non-existent objects live. A philosopher named Alexius Meinong proposes a strange theory, a theory about objects that do not exist, and Meinong argues that there are objects that do not exist, but still have properties, can be talked about, can be thought about, and these non-existent objects populate what Meinong calls the realm of being, a broader category than existence, and examples include the Golden Mountain, which does not exist but is golden and is a mountain, and the round square, which does not exist but is round and square, and Sherlock Holmes, who does not exist but is a detective and lives on Baker Street. And Meinong's theory says we can make true statements about these non-existent objects. Can say truly that the Golden Mountain is golden, even though no Golden Mountain exists, and this creates paradoxes, creates puzzles about the nature of reference and truth. Because how can statements about nothing be true? How can non-existent objects have properties? How can we refer to what does not exist? And this is Meinong's paradox, the puzzle about non-existent objects, about whether they are real in some sense, whether being is broader than existence, whether there are things that do not exist but still have some kind of reality. And this paradox has generated enormous discussion, has led some philosophers to defend Meinong's theory in modified form and others to reject it entirely, to argue that non-existent objects are impossible, are contradictions, and all objects that can be thought about must exist in some sense. Imagine thinking about Sherlock Holmes, picturing the detective, his deerstalker hat, his pipe, his address at 221B Baker Street, and you're thinking about something. Your thoughts have content, have an object, and that object is Sherlock Holmes. But Sherlock Holmes does not exist, was never a real person, is a fictional character invented by Arthur Conan Doyle. And so, what are you thinking about when you think about Sherlock Holmes? What is the object of your thought? And Meinong says the object is Sherlock Holmes himself, a non-existent object, an object that has properties like being a detective and living on Baker Street but lacks the property of existence. And this seems to make sense of how we can think about fictional characters, how we can make true statements about them, but it creates problems because it seems to commit us to a vast ontology of non-existent objects. All the fictional characters, all the impossible objects like round squares, all the merely possible objects that could exist but do not. And this ontology seems bloated, seems to violate parsimony, seems to multiply entities beyond necessity. The paradox sharpens when we consider impossible objects, objects like the round square, which is both round and square, and these properties are incompatible, cannot both be instantiated by a single object. And yet Meinong's theory seems to allow that the round square is both round and square, has both properties despite their incompatibility, and this violates the law of non-contradiction, seems to allow contradictions to be true. And Russell famously criticised Meinong for this, argued that the round square both exists and does not exist. Exists because it has properties and things with properties must exist to have them, and does not exist because that is part of its characterization. And this contradiction shows that Meinong's theory is incoherent, cannot be accepted, and non-existent objects are impossible, and all talk of them must be reinterpreted as talk of something else, talk of ideas or words or possible worlds, but not talk of actual non-existent objects. Visualize Meinong's ontology as having two realms, the realm of existence containing actual objects, like tables and mountains and people, and the realm of being containing all objects, including non-existent ones like golden mountains and fictional characters, and the realm of being is vastly larger, contains everything we can conceive, all possibilities and impossibilities, and only a tiny subset of being also has existence. And Meinong's theory says that statements can be true of objects in the realm of being whether or not those objects exist, and truth is not restricted to existing objects. And this solves certain puzzles about reference, about how we can refer to what does not exist, but creates the paradox of how non-existent objects can have properties, can be subjects of true predications when there is nothing there to have the properties. One response to Meinong's paradox rejects non-existent objects, adopts Russell's theory of descriptions, which analyzes statements about non-existent objects as existential statements that happen to be false, and the golden mountain is golden becomes. There exists something that is golden and is a mountain, and this statement is false because no such thing exists. And fictional statements are understood as prefixed by an implicit fiction operator. In the Sherlock Holmes stories, it is true that Holmes is a detective, and this preserves the intuition that Holmes is a detective, in some sense, while avoiding commitment to non-existent objects. And this Russellian approach has been standard in analytic philosophy, is the orthodox view, treats apparent reference to non-existent objects as disguised quantification or as occurring within the scope of intentional operators. Another response defends Meinong's theory in modified form, accepts that there are non-existent objects, but restricts what properties they can have, distinguishes between nuclear properties like being golden or being a detective, which non-existent objects can have, and extra nuclear properties like existing or being thought about, which are different, and impossible objects like round squares have both roundness and squareness as nuclear properties, but do not violate contradiction because they do not exist, do not have instances in reality, and their properties do not need to be jointly instantiable. And this neo-Meinongian approach preserves some of Meinong's insights while avoiding Russell's objection, and various philosophers, including Terence Parsons and Richard Routley, have developed sophisticated neo-Meinongian theories that handle the paradoxes. A third response appeals to possible worlds, argues that fictional and non-existent objects exist in other possible worlds, are possible but not actual, and when we talk about Sherlock Holmes, we're talking about a possible person, someone who exists in other possible worlds, in worlds where Conan Doyle's stories are true, and this preserves the intuition that Holmes is a detective, is a real object in some sense, while avoiding the paradox of non-existent objects, because Holmes is not non-existent but merely non-actual, exists in other worlds. And possible worlds semantics provides a framework for understanding modality and fiction without Meinongian ontology. Meinong's paradox also raises questions about what it means to exist, about whether existence is a property like others or is somehow special, and Kant argued that existence is not a real predicate, not a property that objects have or lack, but is the presupposition of having properties. And this Kantian view seems to refute Meinong, seems to show that non-existent objects cannot have properties because having properties requires existing, but Meinongians respond that this assumes existence is necessary for predication, that only existing things can have properties, and this assumption is precisely what Meinong denies, and the debate continues about whether existence is a property and whether objects must exist to have properties. The golden mountain glitters in imagination, non-existent but golden, and Sherlock Holmes solves cases in fiction, non-existent but a detective, and the round square defies logic, non-existent and impossible, and Meinong's theory says these are real objects in the broad sense of being, and the paradox asks how this can be, how nothing can be something, how non-existence can have properties, and the answers divide philosophers, some accepting Meinong's insights, some rejecting them entirely, and the paradox persists as a challenge to theories of reference and ontology, a puzzle about what we talk about when we talk about what does not exist, and whether such talk requires real objects or can be explained without them. And Meinong's paradox endures as one of the strangest and most controversial problems in metaphysics, a problem about the boundary between being and non-being, about what counts as real, and about whether existence is the only kind of reality or whether non-existent objects have their own shadowy realm of being. Quine's Gavagai problem? Why we can never know what anyone really means. An anthropologist arrives in a remote village to study an unknown language, a language no outsider has encountered before. And the anthropologist has no translator, no dictionary, no common linguistic framework, only observations and patience, and the method is radical translation. Learning the language from scratch by observing how natives use words in response to events. And one day, A rabbit runs past and a native points and says Gavagai, and the anthropologist writes in the notebook, Gavagai means rabbit. And this seems reasonable, seems like an obvious inference. The native saw a rabbit and said Gavagai, so Gavagai must refer to rabbits. But philosopher Willard Van Orman Quine points out a problem, a deep problem about meaning and translation. Because Gavagai might mean rabbit, but it might also mean undetached rabbit part, or rabbit stage, or collection of rabbit molecules, or instance of rabbithood. And all these translations are consistent with the native's behaviour. All would lead the native to say Gavagai in exactly the same circumstances, whenever a rabbit is present, and there is no fact of the matter, no objective truth about which translation is correct, no way to determine what Gavagai really means. And this indeterminacy is not due to practical limitations, not due to insufficient evidence, but is fundamental, is a consequence of how meaning works. And this is Quine's Gavagai problem, also called the problem of indeterminacy of translation, a challenge to the idea that words have determinate meanings, that translation has right answers, and that we can know what others mean when they speak. Imagine trying to distinguish between Gavagai means rabbit and Gavagai means undetached rabbit part. And you point to the rabbit and the native says Gavagai, and you point to the rabbit's ear and ask whether this is Gavagai, and the native responds, but you do not know whether the response means yes because the ear is an undetached rabbit part, or no, because the ear is not a whole rabbit, or something else entirely. And every test you design, every question you ask, can be interpreted in multiple ways, can be answered consistently by multiple translations, and no amount of observation, no behavioural evidence can definitively settle which translation is correct, because the native's behaviour under all possible circumstances is compatible with multiple interpretations. And Quine argues that this shows meaning is indeterminate, that there is no fact about what Gavagai really means, only different translation manuals that work equally well, that map the native's language onto ours in different but equally legitimate ways. The problem generalizes beyond anthropology to all understanding of language, because even when we share a language, even when we both speak English, the Gavagai problem applies. We cannot be certain that we mean the same thing by our words, that rabbit means to you what it means to me. We might be using different concepts, carved up differently, but our behavior is similar enough that we never notice the difference. And this raises the disturbing possibility that communication is always partial, always approximate, that we never fully understand each other, that meaning is not something objective that words have, but something we impose through interpretation, and different interpretations can fit the evidence equally well, and there is no transcendent perspective from which to judge which interpretation is correct. Visualize meaning as a relationship between words and world, and Quine's point is that this relationship is underdetermined by behaviour, by the evidence available to translators, because infinitely many relationships are consistent with the same behavioural evidence. Infinitely many ways of mapping words to world produce the same observable patterns. And choosing among these possibilities requires going beyond evidence, requires making decisions that are not forced by facts. And these decisions constitute meaning rather than discovering it. And so meaning is partially conventional, partially stipulated, not fully determined by reality. The Gavagai problem challenges referential theories of meaning, theories that say words mean things because they refer to objects in the world, because rabbit refers to rabbits, and water refers to water, and Quine's argument shows that reference is inscrutable, cannot be determined from behaviour alone, because words can be interpreted as referring to different things, different ways of carving up reality, and all interpretations fit the evidence, and so reference is not an objective relation, but is relative to a translation manual, relative to a scheme of interpretation, and different manuals. Different schemes can assign different references to the same words while remaining equally correct. One response to the Gavagai problem accepts the indeterminacy, embraces it as a truth about meaning, argues that Quine is right, that there is no fact of the matter about what words mean beyond what is determined by behavioural evidence, and meaning is holistic, depends on the entire network of beliefs and language practices. And translation manuals are theoretical frameworks that organise this evidence. And like all theories, they are underdetermined by data, and multiple theories fit the same data equally well. And choosing among them involves pragmatic considerations, simplicity, utility, coherence, but not truth in any absolute sense. And this response treats meaning as a human construction, something we create through practices rather than something we discover in nature. Another response denies the indeterminacy, argues that Quine's thought experiment is artificial, that in real translation situations additional evidence is available, evidence about intentions, about how speakers correct each other, about the structure of their conceptual schemes. And this additional evidence narrows down the possibilities, rules out bizarre interpretations like undetached rabbit part, and determines that Gavagai means rabbit in the ordinary sense. And while perfect certainty may be impossible, practical determinacy is achievable, and meaning is objective enough for communication to succeed, for translation to have right and wrong answers. And the Gavagai problem is an epistemological worry, a concern about how we know what words mean, but it does not show that words lack determinate meanings, only that discovering those meanings is difficult. A third response appeals to charity, to the principle that we should interpret speakers as making sense, as having coherent beliefs, as speaking truly most of the time. And this principle constrains translation, rules out interpretations that make speakers irrational or massively mistaken. And while charity does not uniquely determine translation, it narrows the range of acceptable interpretations, and combined with simplicity and other pragmatic virtues, it makes translation tractable, makes it possible to arrive at good translations, even if not perfect ones. And this response treats translation as an interpretive practice, guided by norms rather than as a purely empirical investigation, guided only by behaviour. The Gavagai problem also connects to broader philosophical issues about realism and anti-realism, about whether there are objective facts independent of our theories and languages. Because if meaning is indeterminate, then perhaps reality itself is indeterminate. Perhaps there is no fact about whether rabbits or undetached rabbit parts exist, only different ways of organising experience, different conceptual schemes that carve up the world differently. And Quine's ontological relativity, his claim that what objects exist is relative to a language or theory, follows from the Gavagai problem, from the recognition that reference is inscrutable, that we cannot say what exists absolutely, but only what exists relative to a framework. The anthropologist sits with a notebook, the word Gavagai recorded, the translation uncertain, and the native speaks, and the anthropologist interprets, and communication proceeds approximately, pragmatically, successfully enough for practical purposes, and whether Gavagai really means rabbit or something else remains undetermined, remains a question without an answer. And Quine's problem persists, not as a practical obstacle to translation, but as a philosophical challenge to theories of meaning, as a demonstration that meaning is more elusive than we thought, more dependent on interpretation and less determined by facts. And the Gavagai problem endures as one of Quine's most influential contributions, a thought experiment that changed how philosophers think about language, about meaning, about translation, and about the relationship between words and world. And the problem remains unsolved, perhaps unsolvable, a permanent feature of linguistic philosophy, a reminder that understanding each other is harder than it seems, that meaning is indeterminate, that communication is an achievement rather than an automatic consequence of shared language, and that the gap between what we say and what we mean, between our words and their reference, can never be fully closed. And the rabbit runs past and the native says, Gavagai, and we translate approximately, hopefully, never quite certain that we have understood. Nagel's bat problem: why you can never know what it's like to be anything else. A philosopher contemplates a bat hanging upside down in a cave, navigating through echolocation, emitting high-frequency sounds and listening to the echoes, building a sonic map of the world. And the philosopher asks what it is like to be a bat. What is the subjective character of bat experience? What does echolocation feel like from the inside? And philosopher Thomas Nagel argues that no amount of objective information about bat neuroscience, about bat behavior, about the physics of sonar, can tell us what bat experience is like, because subjective experience has an essential first-person character, a what-it-is likeness that cannot be captured from the third-person objective perspective of science, and the gap between objective description and subjective experience is unbridgeable. And this means that consciousness, at least in its subjective aspect, resists scientific explanation, resists reduction to physical terms. And this is Nagel's bat problem, presented in his famous 1974 paper, What Is It Like to Be a Bat? And the problem illustrates the explanatory gap between physical facts and phenomenal facts, shows that subjective experience involves something that objective science cannot capture, and challenges physicalist theories of mind to explain how subjective character could be accommodated within a purely physical framework. Imagine trying to know what echolocation is like, trying to understand bat experience from the inside, and you learn all the objective facts. Learn about the bat's auditory system, about how it processes echoes, about which brain regions are involved. And this knowledge is real, is valuable, tells you how echolocation works, but it does not tell you what it feels like, does not give you access to the bat's subjective experience, to the phenomenology of navigating by sound. And Nagel's point is that this gap is not due to practical limitations, not due to insufficient technology or incomplete knowledge, but is a fundamental gap between objective and subjective perspectives, between what can be known from outside and what can only be known from inside. And no amount of objective knowledge can bridge this gap, can provide access to subjective experience. The bat problem generalizes beyond bats to any creature with a different sensory modality, a different nervous system, a different form of consciousness. And Nagel uses bats because they are mammals, are relatively similar to humans, yet have a sensory mode, echolocation, that humans lack. And this combination makes the example vivid, makes the gap between human and bat experience clear. And if we cannot know what it is like to be a bat, then we certainly cannot know what it is like to be a fish, an insect, an octopus, creatures whose nervous systems and sensory worlds are even more alien. And this suggests that consciousness, in its subjective aspect, is fundamentally private, is accessible only to the being who has it, and different kinds of consciousness are mutually inaccessible, cannot be fully understood from outside. Visualize the subjective character of experience as the view from inside, the first-person perspective, the what-it-is likeness. And this perspective is essential to consciousness, is what makes consciousness consciousness rather than merely information processing. And Nagel argues that physicalism, the view that everything is physical, must either deny that subjective character exists, which seems false because we all know from our own case that consciousness has a subjective character, or must explain how subjective character could be physical, how objective physical facts could constitute subjective, first-person experiences. And this explanation is what physicalism has not provided, what the bat problem challenges physicalism to provide. One response to the bat problem accepts the explanatory gap, but denies that it shows anything metaphysical, argues that the gap is merely epistemological, is about the limits of what we can know rather than about the nature of reality, and consciousness might be physical, even though we cannot fully understand it from the objective third-person perspective. And just as we cannot know what it is like to be a bat, we also cannot know what it is like to be another human, cannot fully access their subjective experiences. and yet we do not conclude that human consciousness is non-physical. And so the bat problem shows limits of knowledge, but not limits of physicalism, shows that subjective experience has aspects that resist objective description, but not that these aspects are non-physical. Another response argues that future science might bridge the gap, might develop ways of understanding subjective character objectively, might create theories that capture phenomenology in physical terms, and our current inability to imagine how this could be done does not prove that it cannot be done. And Nagel's argument trades on current ignorance, assumes that the gap is permanent, when it might be merely temporary, and this response is optimistic about the prospects for physicalist explanations of consciousness, believes that the hard problem and the bat problem will eventually be solved by scientific progress. A third response from Nagel's position argues that the bat problem reveals something deep about the structure of reality, that consciousness has an irreducibly subjective aspect, an aspect that cannot be captured by objective physical description. And this does not mean consciousness is non-physical in the sense of being immaterial or supernatural, but it means that physicalism, as traditionally conceived, is incomplete, misses something essential about consciousness, and a complete theory of reality must include both objective physical facts and subjective phenomenal facts. And these two kinds of facts cannot be reduced to each other, and this position is sometimes called naturalistic dualism, accepts that consciousness is natural, is part of the natural world, but denies that it is reducible to physics. The bat problem also has implications for artificial intelligence, for whether machines could be conscious, because if we cannot know what it is like to be a bat, then we also cannot know what it is like to be a computer, cannot know whether AI systems have subjective experiences, and the bat problem suggests that behavioral evidence is insufficient, that even if a machine passes every behavioral test, exhibits intelligence, responds appropriately to stimuli, we still cannot know whether there is something it is like to be that machine, whether there is subjective experience behind the behavior, and this creates a permanent epistemic barrier, a limit on what we can know about machine consciousness. The bat hangs in the cave, emitting sounds, perceiving the world through echoes, and its experience is alien, is inaccessible to human understanding. And Nagel's question remains, what is it like? And the answer is we do not know, cannot know, because knowing requires access to the subjective perspective, requires being the bat or having the bat's sensory and cognitive capacities, and neither is possible. And so bat consciousness remains a mystery, remains forever beyond human comprehension. And this mystery is not unique to bats but applies to all consciousness, to the fundamental subjectivity of experience, to the what it is likeness that defines phenomenal consciousness. And Nagel's bat problem endures as one of the most influential thought experiments in philosophy of mind, a vivid illustration of the explanatory gap, a challenge to physicalist theories, and a reminder that consciousness, in its subjective aspect, resists objective description, resists scientific reduction, and remains one of the deepest puzzles about the nature of mind and reality. And the bat flies through the cave, navigating by sound, living its bat life, having its bat experiences, and what those experiences are like remains unknown, remains unknowable. And the problem persists, the gap between objective knowledge and subjective experience, the difference between knowing about consciousness and knowing consciousness from the inside. And Nagel's question echoes, what is it like to be a bat? And no answer comes, no answer can come, and the problem stands as a permanent marker of the limits of objective understanding, the irreducible subjectivity of experience and the mystery at the heart of consciousness. Moore's paradox. The philosopher G.E. Moore identified a peculiar class of statements that seem absurd or irrational to assert, even though they may be true. And these statements take the form, it is raining, but I do not believe it is raining, or I believe it is raining, but it is not raining. And these statements, while not logical contradictions, strike us as deeply strange. as something no rational person would say. And this strangeness is Moore's paradox, a puzzle about the relationship between belief, assertion, and truth that has implications for epistemology, the philosophy of language, and the nature of self-knowledge. Consider the statement, "It is raining, but I do not believe it is raining," and suppose this statement is true. It really is raining, and the speaker genuinely does not believe it. Perhaps they are looking out the window, but not paying attention, or they are in a state of denial. And so the two conjuncts are both true, and there is no logical contradiction. The world can be such that it is raining, and such that someone does not believe it is raining. And yet if someone asserts this statement, if they say out loud, "It is raining, but I do not believe it is raining," the assertion seems absurd, self-defeating, almost incoherent. And the absurdity does not lie in the content of the statement, which may be true, but in the act of asserting it, in the pragmatic dimension of language use. The paradox arises because assertion carries an implicit commitment to belief. When someone asserts that P they normally implicate, even if they do not explicitly state that they believe P, that they take P to be true, and so asserting it is raining implicates that the speaker believes it is raining, but the second conjunct explicitly denies this belief, and so the assertion as a whole both implicates and denies that the speaker believes it is raining, and this creates a pragmatic contradiction, a clash not between the truth conditions of the statement, but between the commitments carried by different parts of the assertion. Ludwig Wittgenstein famously analysed Moore's paradox, arguing that it reveals something important about the grammar of belief, about the way belief and assertion are related, and Wittgenstein suggested that saying "I believe P" is not a report of an inner mental state, not a description of something going on in the mind, but rather a different way of asserting P, a way of committing oneself to P with a certain degree of caution or tentativeness. And if this is right, then I believe it is raining, but it is not raining is paradoxical because it both asserts and denies the same thing. It commits to the truth of the proposition while simultaneously withdrawing that commitment. Others have analysed the paradox in terms of rational constraints on belief and assertion, arguing that rationality requires a certain coherence between one's beliefs and one's assertions. That if you assert P, you should believe P, and if you believe P, you should regard P as true. And so asserting it is raining, but I do not believe it is raining, violates these coherence requirements. It displays a kind of epistemic irrationality, a failure to properly integrate one's assertions with one's beliefs, even if the statement itself is not logically contradictory. The paradox also has a dual form involving belief rather than assertion. Consider the statement, "I believe it is raining, but it is not raining." And again, this may be true. Someone can believe something false, but believing this conjunction seems irrational, because if you believe the first conjunct, that you believe it is raining, and you also believe the second conjunct, that it is not raining, then you are aware that one of your beliefs is false, yet you continue to hold both beliefs. And this seems like a paradigm case of irrationality, holding contradictory beliefs while being fully aware of the contradiction. The more paradoxical statements reveal a kind of blindness that rational agents have about their own beliefs. You cannot rationally believe I believe P, but not P, even though this statement may be true, because believing it requires simultaneously believing P. Since you believe that you believe P, and beliefs about your own beliefs are generally reliable, and believing not P, which is the second conjunct, and so you end up believing both P and not P, which is a straightforward contradiction. And so the more paradoxical belief collapses into an ordinary contradiction when believed, even though it is not a contradiction when merely entertained or stated by someone else. The paradox connects to issues about self-knowledge and the transparency of belief, the idea that we have a special kind of access to our own mental states, that we know what we believe in a way that is different from how we know what others believe. And Moore's paradox suggests that this access is not merely causal or empirical, but involves a kind of rational or conceptual connection, that there are norms governing the relationship between belief and self-ascription of belief, norms that make certain combinations of beliefs irrational even when they are not logically contradictory. The paradox also appears in contexts involving other propositional attitudes. There are more paradoxical statements involving knowledge, such as P is true, but I do not know it, which seem strange to assert even though they may be true. There are billions of truths that any given person does not know, and there are versions involving desire, intention, and other mental states, each revealing similar tensions between the attitude and the self-ascription of that attitude. Some philosophers have argued that Moore's paradox reveals the limits of a purely truth-conditional semantics, the view that the meaning of a sentence is fully captured by its truth conditions, by the conditions under which it is true or false. Because more paradoxical sentences have clear truth conditions, they are true when both conjuncts are true, and yet they are assertorically defective. They cannot be rationally asserted, and this suggests that meaning involves more than truth conditions, that it includes pragmatic dimensions, norms of assertion, and the commitments that speakers undertake when they use language. Others have explored formal models of Moore's paradox using epistemic logic and doxastic logic, systems that formalize reasoning about knowledge and belief. And these formal models can represent the structure of more paradoxical statements and prove that they are not logically contradictory, while also showing why they lead to incoherence when believed or asserted. And this formal work has illuminated the structure of the paradox and connected it to other puzzles in epistemic logic, such as the knowability paradox and the surprise examination paradox. Moore's paradox remains a touchstone in philosophy of mind and language, a simple puzzle that continues to generate insights about the nature of belief, the norms of assertion, the structure of self-knowledge, and the relationship between logic and rationality. And it stands as a reminder that coherence and consistency are more complex than they first appear, that there are ways of being irrational that do not involve believing logical contradictions, that the pragmatics of language use constrain what can be rationally asserted in ways that go beyond the truth or falsity of what is said, and that the relationship between mind and world, between belief and truth, between what we think and what we say, is mediated by norms and commitments that are not fully captured by the formal apparatus of logic. And the statement sits there: it is raining. But I do not believe it is raining. True perhaps, yet absurd, unsayable, a combination of words that no rational speaker would utter. And the paradox persists, a permanent fixture in the landscape of philosophy, a puzzle that illuminates the boundaries of rational thought, the limits of self-knowledge, and the strange logic that governs the relationship between belief and assertion, between what we think and what we can coherently say about what we think. Moore's open question, argument why good cannot be defined. A philosopher claims to have defined goodness, claims that good means pleasure, or good means what evolution favoured, or good means what most people approve of, and the definition is offered with confidence, with arguments and evidence supporting it, and yet G.E. Moore, in his 1903 book Principia Ethica, pointed out a fatal problem with all such definitions, a problem so simple and devastating that it has shaped ethics ever since. And the problem is this: take any proposed definition of good, any equation of goodness, with some natural property, and you can always ask a meaningful question. You can ask, but is that property itself good? And the fact that this question remains open, remains intelligible, and not obviously silly, shows that the definition has failed, shows that good has not been captured by the natural property. And this is Moore's open question argument, a challenge to naturalistic definitions of good that attempts to prove that goodness is indefinable, that it cannot be reduced to any natural fact or property, that it is a simple, unanalyzable concept that we grasp directly through moral intuition, but cannot explain in other terms. Imagine someone says good means pleasant. Pleasure is what good is. And now Moore asks the open question, but is pleasure good? And this question makes sense, is not absurd, is not like asking whether bachelors are unmarried men, where the question is trivially answered by the definition. And the fact that we can meaningfully ask whether pleasure is good shows that good does not mean the same thing as pleasant. Otherwise, the question would be equivalent to asking whether pleasant things are pleasant, which is a meaningless tautology. And since the question is not meaningless, since we can intelligently disagree about whether pleasure is good, the definition must be wrong, must have failed to capture what goodness really is. The same argument applies to any naturalistic definition. If someone says good means evolutionarily advantageous, we can ask, but is what evolution favoured good? And this is an open question. Many people would say no, that evolution produces traits that help survival and reproduction, but not necessarily traits that are morally good, that rape and infanticide might be evolutionarily advantageous in some contexts, but are not good, and so the definition fails. Or if someone says good means desired by most people, we can ask, but is what most people desire good? And again, this is open. We can imagine societies where most people desire things that are actually bad, where popular opinion is mistaken, and so the definition fails again. Moore concluded that good is indefinable, not because we do not know what it is, but because it is a simple, primitive concept, like yellow or existence, something that cannot be broken down into simpler parts or explained in other terms, but must be grasped directly. And we know good through moral intuition, through a kind of perception that is not sensory but intellectual. And different people's intuitions might disagree, but that does not mean goodness is subjective. It might mean that some people perceive moral reality more clearly than others, just as some people have better colour vision, and Moore's position is a form of non-naturalism, the view that moral properties are real but not natural, not part of the physical world studied by science, but a distinct realm of normative facts that exist objectively. The open question argument has generated enormous controversy. Critics argue that it proves too much, that the same reasoning would show that nothing can be defined, because for any definition, we can ask an open question. If water is H2O, we can ask, but is H2O water? And before we learned the chemistry, this question was open. People could meaningfully disagree, and yet we now accept that water is H2O as a correct identity. Not a definition of meaning, but an empirical discovery about what water turns out to be. And perhaps good is like this. Perhaps good is identical to some natural property, not as a matter of meaning, but as an empirical fact about what goodness turns out to be. And the open question shows only that we have not yet discovered which natural property good is, not that no such property exists. Others argue that the open question argument assumes too much about how meaning works, assumes that if two terms mean the same thing, then they must be obviously synonymous. But this is false. Morning star and evening star both refer to Venus, but it was not obvious. People could meaningfully ask whether the morning star is the evening star. And so Moore's test fails. The fact that a question is open does not prove that the terms do not refer to the same thing. And so the open question argument does not establish that good is indefinable, only that the definition is not obvious, not transparent. And this leaves room for naturalistic theories that identify goodness with some natural property as an empirical discovery rather than a conceptual analysis. Visualize Moore's argument as a test applied to proposed definitions. Each definition is presented, good equals X, and Moore applies the test. He asks, is X good? And if the question is intelligible, if it makes sense to ask, if competent speakers can understand the question and disagree about the answer, then the definition fails. X does not capture what good means. And Moore applies this test to definition after definition. Hedonism says good equals pleasure. Moore asks. Is pleasure good? The question makes sense. Test failed. Naturalism says good equals natural property. Why? Moore asks, is why good? The question makes sense. Test failed. And the test seems to show that no natural property can be identical to goodness. That good resists reduction, resists naturalization, stands apart from the world of facts, and refers to something normative, something that cannot be captured by descriptive language. The argument has implications for metaethics, for the question of what kind of thing goodness is. If Moore is right, then moral realism, the view that moral facts exist objectively, must be non-naturalist, must accept that moral properties are sui generis, distinct from natural properties, irreducible to physics or biology or psychology, and this raises questions about how we can know moral facts, how moral properties relate to natural properties, whether moral facts can cause anything or play any role in explaining behaviour. And non-naturalism faces challenges, struggles to explain how we perceive non-natural properties, how they fit into a scientific worldview, whether they're compatible with naturalism about everything else. The open question argument also influenced emotivism and expressivism, non-cognitivist views that deny moral statements are factual claims at all, argue instead that moral language expresses attitudes or emotions rather than describing reality, and these views claim to explain why the open question is always open, because good does not refer to any property, natural or non-natural, but expresses approval or prescribes action. And so asking whether X is good is asking whether to approve of X, whether to pursue it. And this is always an open question, always something we can meaningfully deliberate about. But the non-cognitivists deny Moore's conclusion, deny that goodness is a real property we intuit, argue instead that moral language has a different function, is not in the business of describing reality, but of expressing commitments and guiding action. Moore's argument changed the landscape of ethics, forced philosophers to take seriously the question of whether moral properties are natural or non-natural, whether moral knowledge is empirical or a priori, whether ethics can be reduced to science or remains a distinct domain, and the argument remains controversial. Some see it as a decisive refutation of naturalism. Others see it as a confusion about meaning and reference. And the debate continues, with naturalists proposing sophisticated identities between moral and natural properties, with non-naturalists defending irreducible normativity, and with non-cognitivists denying that moral language describes properties at all. And Moore's open question sits at the centre of these disputes, a simple test that reveals deep issues about meaning, about value, about the relationship between facts and norms, and about whether goodness is something we discover in the world or something we project onto it. And the question remains open, always open, because that is what good does. It resists definition, resists reduction, remains stubbornly normative, always inviting the question, but is that really good? And no answer closes the question, no definition settles it. And Moore's argument endures as a reminder that ethics is not reducible to any other domain, that the normative cannot be fully naturalized, and that goodness, whatever it is, stands apart, indefinable, and irreducible, a primitive concept that we use, but cannot explain. Olbers's paradox, why the night sky is dark when it should blaze with light. Look up at the night sky and you see darkness, scattered stars against a black background, empty space between the points of light. And this seems natural, seems obvious. The sky's dark because there are not many stars, because most of space is empty. But in an infinite, eternal universe filled with stars, this darkness becomes paradoxical, becomes something that should not exist. And this is Olbers' paradox, named after German astronomer Heinrich Wilhelm Olbers, who discussed it in 1823, though the puzzle was recognized earlier by others, including Johannes Kepler and Edmund Halley. And the paradox asks why the night sky is dark, when simple reasoning suggests it should be blazing bright as the surface of the sun, in every direction. The argument proceeds as follows. If the universe is infinite in spatial extent and has existed forever, and if stars are distributed roughly uniformly throughout this infinite space, then every line of sight from Earth, extended far enough, must eventually intersect the surface of a star, because in an infinite universe, with infinite stars, every direction contains a star somewhere along that sight line, perhaps nearby or perhaps trillions of light years away, but somewhere, and so the entire sky should be covered with stellar surfaces, should glow with the brightness of a star, and there should be no dark spaces, no black background, only light, and yet we see darkness. We see mostly empty space with occasional bright stars, and this contradiction is Olbers' paradox. Visualize the reasoning more carefully. Imagine dividing the universe into concentric shells around Earth, like layers of an onion, each shell at a different distance, and count how many stars are in each shell. A shell at distance r has volume proportional to r squared times the shell thickness, because the surface area of a sphere grows as r squared, and if stars are uniformly distributed, then the number of stars in the shell is proportional to r squared. But the brightness of each individual star falls off as 1 over r squared due to the inverse square law of light. Light spreads out as it travels, and so the total brightness contributed by all stars in a given shell is the number of stars times the brightness per star, which is r squared times 1 over r squared. And these factors cancel, and each shell contributes the same total brightness regardless of distance. And since there are infinitely many shells in an infinite universe, the total brightness is infinite, and the sky should be infinitely bright. And even if we account for stars blocking each other, eventually every sight line intersects a star, and the sky should glow uniformly with the brightness of stellar surfaces. The resolution of Olbers' paradox involves recognizing that the universe is not infinite and eternal in the way the paradox assumes. Modern cosmology tells us that the universe has a finite age, about 13.8 billion years, and light travels at a finite speed, and so we can only see light from stars within our observable horizon, stars whose light has had time to reach us. And this limits the number of stars we can see, and more importantly, the universe is expanding, and distant stars are receding from us, and their light is redshifted, stretched to longer wavelengths and lower energies by the expansion of space. And this redshift dims distant starlight. And for sufficiently distant stars, the redshift is so extreme that their light is shifted into the infrared or radio spectrum, invisible to our eyes. And the combination of finite age and cosmological expansion means that only a finite amount of starlight reaches us, and the night sky is dark. Not because stars are sparse, but because the universe has not existed long enough for light from all stars to reach us, and because expansion dims the light from distant sources. Another factor is the finite lifetime of stars. Stars are not eternal. They form, they shine for millions or billions of years, and they die. And in a finite age universe, not all regions have had time to form stars, and not all stars have been shining throughout cosmic history, and so the background radiation from stars is further reduced. And these factors combine to ensure that the night sky is dark despite the vast number of stars in the universe. The paradox also touches on thermodynamics and equilibrium, because if the universe were infinite, eternal, and static, with stars distributed uniformly, then eventually the radiation from all these stars would fill space uniformly. Space would reach thermal equilibrium with stellar surfaces, and everything would be at the same temperature as the surface of a star, about 6,000 degrees Kelvin, and Earth would be vaporized, life would be impossible, and the darkness of the night sky is evidence that the universe is not in thermal equilibrium, is not static and eternal, but is instead dynamic, expanding, and young. Olbers' paradox played a role in the development of modern cosmology. It was one piece of evidence that the universe cannot be static and eternal, that something must be different about the large-scale structure of space and time. And when Edwin Hubble discovered in the 1920s that the universe is expanding, that distant galaxies are receding from us, this provided a natural resolution to Olbers' paradox. The expansion redshifts and dims distant light, preventing the accumulation of infinite brightness, and the finite age of the universe, confirmed by observations of the cosmic microwave background and the distribution of galaxies, completes the resolution, ensuring that we see only a finite amount of cosmic history, only the light from stars within our past light cone. The paradox also has poetic resonance. It asks why there is darkness, why night exists, why space is not filled with light. And the answer is that darkness is a consequence of time and change, of the universe having a beginning, of stars being born and dying, of space expanding and carrying light away. And darkness becomes not an absence, but a presence, not a void, but a canvas. Evidence of cosmic history, evidence of the dynamic evolving universe we inhabit. And the dark night sky, far from being empty or boring, is rich with information. Tells us about the finite age of the cosmos, about the expansion of space, about the distribution and evolution of stars and galaxies, and Olbers' paradox, resolved but not forgotten, remains a reminder that even simple observations, like the darkness of night, can contain profound mysteries, can require deep theories to explain, and can reveal fundamental truths about the nature of the universe. The stars shine against the darkness, scattered lights in an empty sky, and the darkness itself is meaningful, is informative, is the signature of a finite age expanding universe. And Olbers' paradox, resolved by modern cosmology, endures as a teaching tool, as an illustration of how seemingly simple questions can have complex answers, and as a monument to the human capacity to wonder about the ordinary, to see puzzles where others see only the familiar, and to pursue those puzzles until the universe reveals its secrets. Parfit's teletransportation paradox. Imagine a future where technology allows instant travel across vast distances through a process called teletransportation. A device scans your body down to the atomic level, recording the exact position and state of every particle, and then transmits this information to a distant location where another device reconstructs you perfectly, assembling a body atom by atom according to the transmitted blueprint. And the reconstruction is flawless, every memory intact, every scar reproduced, every thought continued, and the reconstructed person steps out of the receiving chamber, believing themselves to be you, feeling no discontinuity, no sense that anything strange has occurred. The philosopher Derek Parfit asked a disturbing question about this process. Are you the person who steps out of the receiving chamber, or did you die in the scanning chamber? And a copy, a duplicate with all your memories and personality, is now living your life. And if the scanning process destroys the original body as it records the information, then perhaps it is still you, continuous in some sense. But what if the original body is not destroyed? What if the scanner leaves you standing in the departure chamber, intact and alive, while the reconstruction appears in the receiving chamber? And now there are two of you, both with equal claim to being the original, both feeling that they are you, and if both are you, then identity has become plural. But if only one is you, then which one and what criterion could possibly distinguish them when they are physically and psychologically identical? Parfit used this thought experiment to challenge the intuition that personal identity is what matters in survival, arguing that what matters is not identity, not being numerically the same person, but rather psychological continuity and connectedness, the preservation of memories, personality, beliefs, desires, and ongoing projects. And if these are preserved, then survival has occurred even if strict identity has not. And so, the reconstructed person is you in every way that matters, even if they are not numerically identical to the original you. And the question of whether identity is preserved is a question about what we care about rather than a deep metaphysical fact. The paradox becomes more troubling when variations are introduced. Suppose the teletransportation device malfunctions and creates not one, but two reconstructions, both perfect, both claiming to be you, and now identity must branch, which seems impossible because identity is supposed to be a one-to-one relation. A thing is identical only to itself, and yet both reconstructions have an equal claim, and if identity is not preserved in this case, then why should it be preserved in the normal case where only one reconstruction appears? And if it is not preserved, then every time you use the teletransporter, you die, and a new person with your memories takes your place, living a life they falsely believe is a continuation of yours. Parfit embraced the conclusion that identity is not what matters, that we should care about psychological continuity rather than numerical identity, and that the concept of a persisting self, a single unified person who endures over time, is less important than we ordinarily think. That what makes your future self matter to you now is not that they are literally the same person, but that they are psychologically connected to you in the right ways, and if those connections can branch or spread across multiple individuals, then so be it. Identity is not sacred, not the ultimate ground of value or concern. The teletransportation paradox has implications for how we think about personal survival, about whether what matters in death is the cessation of psychological continuity or the cessation of biological life, about whether uploading consciousness to a computer or creating digital copies would constitute survival or merely the creation of simulacra, and about whether the self is a metaphysical entity or a convenient fiction we use to organize experience. The paradox also challenges intuitions about moral responsibility, because if identity is vague or plural, then questions about who is responsible for past actions or who deserves future rewards become murky, and the unity of the person, which underpins much of ethics and law, begins to dissolve. Parfit's teletransportation scenario remains one of the most powerful thought experiments in philosophy, a story that uses imaginable technology to expose deep questions about identity, survival, and what it means to be a person, forcing recognition that the boundaries of the self, like the boundaries of clouds and cats, may be far less clear and far less important than common sense suggests, and that the question of whether you survive. Teletransportation may have no determinate answer, or many answers, or may simply be the wrong question to ask. Richard's paradox. In 1905, the French mathematician Jules Richard discovered a paradox that strikes at the heart of how language and mathematics interact, revealing that certain kinds of definitions can generate contradictions no matter how carefully they're constructed. Consider the set of all real numbers that can be defined in a finite number of words using the English language. And this set seems reasonable at first because most numbers we ever think about can be described in some way. Pi is the ratio of a circle's circumference to its diameter. The square root of 2 is the length of the diagonal of a unit square, and so on. Since there are only finitely many words in the English language and only finitely many ways to arrange them into sentences of any given length, there can only be countably many such descriptions, which means there are only countably many real numbers that can be defined in this way. Yet the real numbers are uncountable, as Georg Cantor proved, which means there must exist real numbers that cannot be defined in any finite number of English words, numbers that are forever beyond the reach of language, numbers that exist but cannot be named or described or pointed to in any way. Now comes the paradox. Consider the real number defined as follows. Let it be the first real number in the set of all real numbers that cannot be defined in a finite number of English words, arranged in some standard ordering, such as numerical order. This definition appears to successfully define a specific real number, and the definition itself uses only a finite number of English words, which means the number it defines belongs to the set of numbers that can be defined in a finite number of words, but the definition explicitly states that the number belongs to the set of numbers that cannot be defined in a finite number of words, and so the contradiction emerges, sharp and unavoidable. If the number can be defined, then it does not belong to the set of undefinable numbers, but the definition picks it out precisely as a member of that set. And if it cannot be defined, then the definition fails to refer to anything at all, and yet the definition seems perfectly coherent, grammatically correct, and mathematically precise. Richard's paradox exposes a fundamental problem with the concept of definability, the idea that we can cleanly separate describable objects from indescribable ones, because the act of describing the indescribable creates a loop that collapses into contradiction. Some logicians argue that the phrase cannot be defined in a finite number of words is itself vague or improperly formalized, that it mixes informal natural language with formal mathematical concepts in a way that generates confusion, and that a more rigorous treatment would prevent the paradox from arising. Others suggest that the paradox reveals a hierarchy in language, that definitions must be made within specific formal systems, and that talking about all possible definitions requires stepping outside the system into a meta-language, and that mixing these levels is where the contradiction appears. Alfred Tarski developed this idea into a full theory of truth and definability, showing that no language can fully express its own semantic concepts without risking paradox, that truth and definability must always be relativized to a particular formal system, and that higher order languages are needed to talk about lower order ones. Richard's paradox also influenced the development of computability theory, because the question of whether a number can be defined in a finite number of words is closely related to whether it can be computed by a finite algorithm, and paradoxes like Richard's helped clarify the distinction between computable and non-computable reals. The paradox remains a haunting reminder that language, even mathematical language, has limits, that not everything that exists can be captured in words, and that the boundary between the describable and the indescribable is not as stable as it first appears. Russell's paradox. In the year 1901, a young mathematician named Bertrand Russell discovered a contradiction so profound that it shattered the foundations of mathematics and forced an entire generation of logicians to rebuild their discipline from the ground up. And this contradiction became known as Russell's paradox, a simple question about sets that revealed a fatal flaw in the way mathematicians understood collections and categories. A set is merely a collection of objects, and sets can contain anything: numbers, colours, ideas, even other sets. And at first this seems harmless enough. A set of all chairs, a set of all prime numbers, a set of all books ever written. Some sets contain themselves as members and some do not. And this too seems straightforward. A catalogue of all catalogues would include itself because it is also a catalogue, while a list of all fruit does not include itself because a list is not a fruit. Russell posed a deceptively innocent question: consider the set of all sets that do not contain themselves. Does this set contain itself? And the mind stumbles immediately into contradiction. If the set contains itself, then by definition it should not contain itself, because the rule states it only includes sets that do not contain themselves. But if it does not contain itself, then it must include itself, because it fits the criteria perfectly. And so the paradox loops without end, a perfect logical knot that cannot be untied. This was not merely a clever riddle or a philosophical curiosity, it was a disaster for mathematics, because at the time, mathematicians believed they could organize all of mathematical knowledge using set theory, a system proposed by Georg Cantor that treated sets as the fundamental building blocks of reality. But Russell's paradox proved that naive set theory was inconsistent, that it allowed contradictions to exist within its structure, and if contradictions are permitted, then anything can be proven true or false, rendering the entire system useless. Russell himself compared the paradox to a barber in a village who shaves all and only those men who do not shave themselves. And the question arises, does the barber shave himself? And if he does, then he should not, because he only shaves men who do not shave themselves. But if he does not, then he must, because he shaves all men who do not shave themselves. And the loop tightens again. Mathematicians scrambled to patch the damage, and various solutions emerged over the following decades. Zermelo and Frankel developed a new version of set theory that imposed strict rules about which sets could exist, forbidding the kind of self-reference that allowed Russell's paradox to form, while type theory introduced hierarchies that prevented sets from containing themselves by assigning different logical levels to different kinds of objects. Others embraced paraconsistent logic, systems that allow contradictions without collapse, or rejected the entire project of grounding mathematics in set theory, seeking new foundations altogether. Russell's paradox also influenced philosophy beyond mathematics, touching on questions of language, meaning, and self-reference, revealing that not all grammatically correct statements are logically coherent, that some sentences create traps from which reason cannot escape. The paradox appears in unexpected places. In computer science, where recursive definitions can cause programs to crash, in legal systems where laws reference themselves in contradictory ways, in everyday thought whenever categories attempt to classify themselves. It stands as a reminder that even the most rigorous systems of thought contain limits, that logic itself is not immune to paradox, that the quest for certainty and completeness may be forever haunted by statements that twist back on themselves and devour their own meaning. The Abilene Paradox: Why Groups Choose What Nobody Wants. A family sits on a porch in Coleman, Texas, on a hot afternoon, comfortable, playing dominoes, and the father-in-law suggests driving to Abilene for dinner, 53 miles away in a car without air conditioning. And the suggestion is not enthusiastic, is tentative, but the son-in-law says sure, sounds good. Not because he wants to go, but because he assumes others want to go, and he wants to be agreeable. And the wife says yes if you all want to go, and the mother-in-law says of course, and they all pile into the car and drive to Abilene in dusty heat, arrive hot and tired, eat mediocre food, drive back exhausted, and sitting on the porch again, someone admits they didn't really want to go, and then everyone admits they didn't want to go, admits they only agreed because they thought others wanted it, and the entire group took an action that no individual wanted, chose an outcome that everyone preferred to avoid. And this is the Abilene Paradox, described by management professor Jerry Harvey, a phenomenon where groups make decisions that contradict the preferences of all members, where collective action diverges from individual preferences, not through majority rule or compromise, but through misperception, through failure to communicate, through assumptions about what others want. And the paradox reveals that agreement is not always consensus, that unanimous decisions can be unwanted by everyone. And the Abilene Paradox shows a different kind of collective irrationality from Condorcet cycles or voting paradoxes, shows irrationality that arises from social dynamics, from conformity pressure, from reluctance to dissent. And the paradox remains relevant for understanding group decision-making, for recognizing that groups can fail not just through conflict, but through false consensus, through everyone going along with what nobody wants. Imagine the psychology of each family member. Each sits on the porch comfortable, each prefers staying home, but each hears the suggestion and thinks, well, if someone is suggesting it, they must want it. I don't want to be the one who ruins everyone's plans. I should be agreeable, go along, be a team player. And so each agrees despite preferring to stay, and no one voices their actual preference. No one says I'd rather stay home. And the group collectively creates a false impression, creates the appearance of consensus when none exists, and everyone interprets others' agreement as reflecting genuine preference rather than social accommodation. And this mutual misperception drives the group toward an outcome no one wants. And the paradox unfolds. The trip is taken, the unwanted dinner eaten, and only afterward does truth emerge. Does communication clarify that everyone preferred staying home? And the group confronts the absurdity, the recognition that they did something no one wanted through failure to communicate authentically. The Abilene paradox differs from groupthink, where group members genuinely conform their preferences to the group, genuinely come to believe the group view. And Abilene involves no genuine preference change, involves only misperception, only assumption about what others want. And members maintain their private preferences, but suppress them out of social pressure, out of desire to be agreeable. And this suppression is the source of the paradox, creates the gap between public agreement and private preference, and the gap allows groups to pursue actions that everyone opposes. And breaking the paradox requires someone to voice dissent, to say, actually, I'd prefer not to go. And this dissent can reveal that others feel the same, can break the false consensus, but dissent is risky, is socially uncomfortable, requires challenging what appears to be group preference. And most people avoid this, prefer to go along, and the paradox persists. Visualize the Abilene paradox as a coordination failure, where the optimal outcome requires everyone to reveal their true preferences, requires honest communication, but social norms and psychological tendencies prevent this, create pressure toward agreement, toward accommodation, toward not rocking the boat. And these pressures are strongest when relationships matter, when group harmony is valued, when dissent risks social costs and family dinners and work teams and community groups all face Abilene risks. All can make decisions that no one wants, through false consensus, through failure to communicate authentically. And the paradox shows that agreement is not always good, that unanimous decisions can be wrong, that groups need mechanisms for authentic communication, need cultures that encourage dissent, need permission to disagree. One lesson from the Abilene paradox is the importance of honest communication, of creating environments where people feel safe expressing disagreement, where dissent is welcomed rather than punished. And organizations that suffer repeated Abilene paradoxes often have cultures of false harmony, have norms that discourage challenging proposals, have leaders who interpret dissent as disloyalty, and these cultures create conditions for Abilene, create pressure toward agreement, and preventing the paradox requires changing culture, requires valuing truth over harmony, requires encouraging people to voice concerns. And this is difficult, requires conscious effort, requires leadership that models disagreement, that rewards dissent, that avoids shooting messengers. Another lesson is about decision-making procedures, about how groups can avoid Abilene through structured processes, through anonymous voting, through devil's advocate roles, through explicit checking for consensus, through asking not just who agrees, but who disagrees and why. And these procedures create space for dissent, create permission to voice opposition, and reduce pressure toward false consensus. And effective groups use these procedures systematically, build them into decision-making, recognize that surface agreement may hide opposition, and these procedures are especially important for high-stakes decisions, for commitments that are costly to reverse. And the trip to Abilene is costly, is unpleasant for everyone, and could have been avoided with better communication. The Abilene paradox also appears in organizational settings, in corporations where teams pursue strategies that no one really supports, in committees that adopt policies no member wants, in groups that invest in projects everyone privately doubts. And these organizational Abilenes are costly, waste resources, damage morale, produce outcomes that serve no one's interests. And preventing them requires organizational awareness, requires training people to recognize Abilene dynamics, requires creating cultures where speaking up is safe, where dissent is valued, and many organizations fail at this. Have cultures of deference, have hierarchies, where subordinates agree with superiors even when privately opposed. And these cultures are Abilene prone, create repeated paradoxes, and organizational effectiveness requires breaking these patterns. Some argue that the Abilene paradox is overstated, that genuine cases are rare, that most group decisions reflect genuine preferences of at least some members, and while everyone agreeing despite everyone opposing is uncommon, partial Abilene is more common, where some members oppose but remain silent, and the group pursues a course that a vocal minority supports while a silent majority opposes, and this partial Abilene is still problematic, still produces suboptimal outcomes, and preventing it still requires encouraging dissent, requires creating safety for opposition. The paradox also raises questions about responsibility, about who is responsible when groups make decisions no one wants, and the answer is everyone and no one. Everyone contributed through silence, through false agreement, through failure to voice opposition, but no one individually caused the outcome. No one individually chose wrongly. Each made a reasonable social decision to accommodate perceived group preferences, and the collective outcome is worse than any individual action merited, and this shows how social dynamics can produce results that exceed individual culpability, can create group failures that no individual intended, and avoiding such failures requires collective awareness, requires group-level solutions, requires changing communication patterns and decision procedures. The family sits on the porch afterward, hot and tired and annoyed, and someone admits they didn't want to go, and the admissions cascade. And everyone realizes the absurdity, realizes they collectively did something no one wanted, and the Abilene paradox is revealed, and laughter mixes with frustration, and the lesson is learned. The importance of honest communication, the danger of false consensus, the need to voice dissent, and the paradox remains a permanent reminder that groups can fail not just through conflict, but through excessive agreeableness, through mistaken assumptions about others' preferences, through social pressures that suppress authentic communication, and the Abilene paradox endures as a cautionary tale about group decision-making, a demonstration that agreement is not always consensus, that unanimous decisions can be wrong, and that preventing collective irrationality requires creating environments where dissent is safe, where truth is valued over harmony, and where groups communicate authentically rather than accommodating falsely. Synesthesia. Paradox: why numbers have colours and sounds have tastes. A person looks at the number 5 and sees it as blue, not imagines it as blue, not associates it with blue, but actually sees blue, experiences colour as an intrinsic property of the number. And another person hears music and tastes chocolate, hears certain chords, and the taste appears involuntarily, automatically. And these experiences are synesthesia, are cross-modal sensory experiences where stimulation in one modality produces perception in another, and synesthesia is not metaphor, is not learned association, is a genuine perceptual phenomenon experienced by roughly 4% of the population. And the paradox is that synesthetes experience properties that are not physically present, see colours that are not in the stimulus, taste flavours that have no source, and yet these experiences are consistent, are reliable. The same numbers always evoke the same colours, the same sounds always evoke the same tastes, and this reliability distinguishes synesthesia from imagination or association, shows that synesthesia is automatic, is perceptual rather than cognitive, and the phenomenon reveals something fundamental about how the brain is organised, shows that sensory modalities are not strictly separate, but can communicate, can influence each other, and synesthesia represents an extreme of this cross-modal interaction, represents a neural architecture where connections between sensory areas are stronger than normal, are sufficient to produce conscious experiences in one modality when another is stimulated. Imagine being a grapheme colour synesthete, the most common form where letters and numbers evoke colours, and you read this text and every letter has its own colour, A is red, B is green, C is yellow, and the colours are vivid, are as clear as real colours, are not vague or imagined but are perceptually present. And when you see the letter A, you cannot help but see red. The colour is automatic, is triggered by the visual form of the letter, and this colouring happens for all letters and numbers, creates a richly coloured experience of reading. And while this might sound beautiful, it can also be distracting, can interfere with reading when the printed colours conflict with synesthetic colours, can create confusion. And yet for synesthetes, this is normal, is how the world has always looked. And they're often surprised to learn that others do not experience letters as coloured, that the colours are unique to synesthetes. Synesthesia demonstrates that perception is not modular, is not strictly segregated by sensory modality, and in synesthetes there is cross-activation. There are connections between sensory areas that do not exist or are weaker in non-synesthetes, and these connections allow activity in one area to trigger activity in another. And when grapheme area, the region that processes letter and number shapes, is activated, it also activates colour area, the region that processes colour, and this cross-activation produces the experience of coloured letters. And neuroimaging studies have confirmed this, have shown that when synesthetes see numbers, colour areas of visual cortex are activated, are lit up. And this activation is automatic, is bottom-up, is not produced by conscious thought or imagination, but is triggered by the stimulus itself. Visualize the brain as having sensory areas that are normally separate: visual area, auditory area, taste area, and these areas process their respective inputs and pass information to higher level regions. But in synesthetes there are additional connections. There are pathways between sensory areas that allow direct crosstalk, and these pathways are the neural basis of synesthesia, are what allows stimulation in one modality to produce experiences in another. And the connections are not learned, are not created through experience, but are developmental, are present from early life. And synesthesia is lifelong, is consistent. The same cross-modal experiences occurring throughout the synesthete's life. The synesthesia paradox is that these experiences are perceptual, are as real as any other perception, and yet the properties perceived are not present in the stimulus. The number 5 is not blue, is black on white, and yet the synesthete sees blue. And this challenges theories that say perception is veridical, is accurate, is a representation of physical reality. And synesthesia shows that perception can include properties that are not in the world, that are generated internally, and yet these properties feel external, feel like properties of objects rather than like internal mental states. And this raises questions about the nature of perception, about what it means for perception to be of something, about whether all perception involves some degree of construction, some degree of adding properties that are not in the stimulus. One theory of synesthesia is that everyone is born with extensive cross-modal connections, that infant brains have connections between all sensory areas, and during development, most of these connections are pruned or eliminated, and sensory areas become more segregated. And in synesthetes, some of these early connections are preserved, are not pruned, and this preservation allows the cross-modal experiences to continue into adulthood. And this theory is supported by evidence that infants show some synesthetic effects, show cross-modal correspondences, and that synesthesia runs in families, has a genetic component, suggesting that genes that regulate synaptic pruning are involved. Another theory is that synesthesia involves disinhibition, involves normally present connections between sensory areas that are usually inhibited, are suppressed, and in synesthetes this inhibition is weakened, is less effective, and so the connections are active, allow cross-activation, and this theory is supported by evidence that synesthesia can be induced temporarily in non-synesthetes through drugs that reduce inhibition, through hypnosis, through sensory deprivation, suggesting that the neural machinery for synesthesia is present in everyone, but is normally inhibited, and synesthetes have less inhibition, have more open channels between sensory areas. Synesthesia also has practical implications. Some synesthetes report that their experiences are useful, provide memory aids, make information more distinctive, easier to remember, and some musicians with sound-colour synesthesia report that the colours help with composition, with understanding musical structure, and some artists deliberately cultivate synesthetic experiences, use them as sources of creativity. And understanding synesthesia has implications for education, for recognising that people process information differently, that sensory experiences vary across individuals, and that teaching should accommodate these differences, should recognise that some students have richly coloured experiences of letters and numbers, while others do not. The phenomenon also raises questions about consciousness, about qualia, about the subjective properties of experience, because synesthetes have different qualia than non-synesthetes, have colour experiences that others do not, and this shows that consciousness is not uniform, is not the same across individuals, and qualia vary, and this variation is not just quantitative, is not just more or less of the same experience, but is qualitative, involves entirely different types of experience, and this challenges theories that say all consciousness is universal, is the same for everyone, and supports theories that say consciousness is individual, is constructed by each brain in potentially different ways. And synesthesia is one example of this variation, is one way that consciousness can differ. Some philosophers argue that synesthesia shows that perception is not representational, does not represent external properties, because the colours seen by graphema colour synesthetes do not represent anything in the world. The number 5 is not blue, and yet the colour is perceived, and this challenges representational theories of perception, suggests that perceptual experiences are not always representations of external properties but can be internally generated responses. And synesthesia is a case where the response includes properties that are not being represented, and this raises questions about what makes perception representational, whether all aspects of perception are representations or whether some are merely responses are produced by the perceptual system without representing anything external. The number appears black on white, and the synesthete sees blue, vivid and automatic. The colour is as real as the number, is as perceptually present, and yet the colour is not there, is not in the stimulus, is generated by the brain, is a cross-modal activation, and the synesthesia paradox remains. Perception includes non-veridical properties, includes experiences that do not correspond to stimulus properties, and yet these experiences are automatic, are reliable, are as perceptually real as any other, and synesthesia endures as one of the most fascinating phenomena in neuroscience, a demonstration that sensory modalities are not strictly separate, that cross-modal connections exist, that perception can include internally generated properties, and that consciousness varies across individuals, includes experiences that are unique, that are not shared by everyone, and the colours remain overlaid on letters, triggered by sounds, evoked by tastes, and the cross-modal world of synesthetes continues, different from the world non-synesthetes perceive, richer in some ways, more confusing in others, and the phenomenon persists. The Allais paradox. Maurice Allais, a French economist and Nobel laureate, presented a pair of choices in 1953 that revealed a systematic pattern of preferences violating the independence axiom of expected utility theory, and this became known as the Allais paradox, one of the most influential demonstrations that human decision-making deviates from the prescriptions of standard rational choice theory. And the paradox shows that people's preferences can be influenced by irrelevant alternatives, by outcomes that occur in both options and should therefore cancel out, yet somehow affect which option is chosen. The first choice involves two lotteries. Lottery A offers a certain gain of $1 million, while Lottery B offers a 10% chance of winning $5 million, an 89% chance of winning $1 million and a 1% chance of winning nothing. And when faced with this choice, most people prefer Lottery A, the certain million, preferring the sure thing to the gamble, even though the gamble has a higher expected value. And this preference reflects risk aversion, a common and generally accepted feature of human decision-making. The second choice involves two different lotteries. Lottery C offers an 11% chance of winning $1 million and an 89% chance of winning nothing, while Lottery D offers a 10% chance of winning $5 million and a 90% chance of winning nothing. And when faced with this choice, most people prefer Lottery D, the gamble with the higher potential payoff, accepting the slightly lower probability of winning in exchange for the much larger prize. The paradox emerges when these two preference patterns are analysed together, because the independence axiom of expected utility theory requires that if Lottery A is preferred to Lottery B, then Lottery C should be preferred to Lottery D. And the reason is that Lotteries A and B differ from Lotteries C and D only in that there is an 89% chance in both A and B of receiving $1 million, and in both C and D this 89% outcome is replaced with winning nothing, and this replacement should affect both lotteries equally, should not change the preference order, because the independence axiom says that preferences between lotteries should depend only on outcomes where the lotteries differ, not on outcomes that are the same in both. And the 89% probability mass is shifted in the same way for both pairs, and so if you prefer A to B, you should also prefer C to D. And if you prefer D to C, you should also prefer B to A. The typical pattern of preferences, A over B and D over C, cannot be represented by any utility function satisfying the expected utility axioms. And so the Allais paradox demonstrates that people systematically violate the independence axiom, that their preferences are sensitive to common outcomes in ways that expected utility theory does not permit. And this violation is robust, appearing in experiments with diverse populations, with real monetary stakes, with careful experimental design, and the paradox cannot be dismissed as error or confusion, but represents a genuine feature of human decision-making. The paradox has inspired alternative theories that can accommodate the observed preferences, including prospect theory developed by Daniel Kahneman and Amos Tversky, which modifies expected utility theory by introducing reference points, by treating gains and losses differently, by allowing for probability weighting where people overweight small probabilities and underweight large probabilities. And these modifications can explain the Allais preferences, because in the first choice, the certainty of $1 million receives extra weight, making Lottery A more attractive, while in the second choice the small probabilities are overweighted, making the 10% chance of $5 million in Lottery D seem more appealing than the 11% chance of $1 million in Lottery C. Other theories include regret theory, where people anticipate the regret they would feel if they made the wrong choice. And this anticipated regret influences preferences in ways that violate independence, because the certain million in Lottery A avoids the regret of choosing the gamble and losing everything, while the choices between C and D do not have this asymmetry. And rank-dependent utility theory, which generalizes expected utility by allowing the utility of lotteries to depend not just on outcomes and probabilities, but on the rank ordering of outcomes, and this allows for preferences that violate independence while maintaining other desirable properties. The Allais paradox raises normative questions about rationality. Some argue that the independence axiom is a fundamental requirement of rational choice, that violating it leads to incoherence, to preferences that can be exploited through Dutch books or money pumps, to decision-making that is systematically suboptimal, and that people who exhibit Allais preferences are making mistakes and should revise their preferences to conform to expected utility theory. While others argue that the independence axiom, while mathematically convenient, is not a necessary condition for rationality, that it does not capture important aspects of how people value uncertain prospects, that preferences like those in the Allais paradox reflect legitimate concerns about certainty, regret, and the context of choice, and that we should revise our normative theories to accommodate these preferences rather than dismissing them as irrational. The paradox also has practical implications for economics and policy, because if people systematically violate independence, then markets may not function as standard theory predicts. Risk preferences may be context-dependent. Insurance and investment decisions may be influenced by framing effects, and policies designed to maximize expected utility may not align with what people actually prefer. And understanding these deviations from expected utility helps explain phenomena like the equity premium puzzle, the disposition effect, and other anomalies in financial markets and economic behavior. The lotteries sit before you, the choices must be made, and your preferences, revealed through your choices, tell a story about how you value certainty and risk, about how you weigh probabilities and outcomes, and the story violates the axioms of rational choice, violates the clean mathematical structure of expected utility theory, and yet the choices feel reasonable, feel justified, feel like they reflect something important about value and uncertainty that the theory misses, and the paradox persists. The gap between theory and behavior remains. The independence axiom is violated again and again in experiments and in life, and decision theorists must choose. Either insist that the axiom is normatively binding and that violators are irrational, or acknowledge that the axiom is too strong, that rational choice is more complex than expected utility allows, and that new theories are needed to capture the richness of human decision-making. And the Allais paradox remains a landmark, a decisive demonstration that classical rational choice theory does not fully describe or prescribe human behavior, a challenge that spawned new theories and new research programs, and a reminder that rationality is contested, that what counts as a reasonable choice depends on assumptions and frameworks that are themselves open to question, and the lotteries remain, the choices remain, the preferences remain, and the paradox endures, unsolved in the sense that no consensus has emerged about whether the preferences are rational or irrational, about whether we should revise our theories or our preferences, about whether independence is a negotiable axiom or a non-negotiable requirement. And the debate continues. Philosophers and economists and psychologists arguing about what rationality requires, about what humans actually do, and about the relationship between these two questions. The arrow paradox. Motion seems so simple, so obvious. An arrow flies through the air from bow to target, and no one doubts that it moves. Yet the ancient Greek philosopher Zeno of Elea posed a question that has troubled thinkers for over 2,000 years, a question about whether motion is even possible at all. And this is the arrow paradox, one of Zeno's many arguments against the reality of change and multiplicity. Consider an arrow in flight, frozen at a single instant of time. At that precise moment, the arrow occupies a specific region of space exactly equal to its own length and width. It is not in two places at once. It is simply where it is motionless, static, indistinguishable from an arrow at rest. At the next instant, the same is true. The arrow occupies a space equal to itself, motionless at that frozen moment, and at the next instant, and the next. And if time is composed of a sequence of such instants, then at every instant the arrow is motionless. And if the arrow is motionless at every instant, then how can it be said to move at all? For motion would require the arrow to be in more than one place at a single instant, or to be in a state of transition rather than a state of rest, and yet at any given instant there is no motion, only position. Zeno used this paradox to support the Eleatic philosophy of Parmenides, which held that change and motion are illusions, that reality is a single, unchanging whole, and that the apparent diversity and movement we perceive are mere deceptions of the senses. The arrow paradox strikes at the very concept of instantaneous velocity. The idea that an object has a speed at a single moment in time, and Aristotle attempted to refute Zeno by arguing that time is not composed of indivisible instants, but is continuous. That motion is not a series of static positions, but a process that unfolds over intervals, and that the paradox arises only if we mistakenly treat time as a collection of frozen moments, rather than a flowing continuum. Modern physics offers a different resolution through calculus, where velocity is defined as the derivative of position with respect to time, a limit that describes how position changes as the time interval approaches zero. And in this framework, instantaneous velocity is a well-defined concept. The arrow does have a speed at each moment, even though speed is not a property that can be observed in a single instant, but only inferred from the relationship between position and time. Yet some philosophers argue that the arrow paradox still points to something genuine and unresolved, a mystery about how the static and the dynamic relate, how a series of stillnesses can add up to motion, how being in a place can somehow become moving between places. Quantum mechanics adds another layer to the puzzle, because at the subatomic level, particles do not have definite positions and velocities simultaneously. The Heisenberg uncertainty principle states that the more precisely we know a particle's position, the less precisely we can know its momentum. And in some sense, the arrow paradox prefigures this strange quantum behavior, the idea that motion and position are not entirely compatible descriptions of reality. The paradox also connects to debates about the nature of time itself, whether time is discrete or continuous, whether it flows or is an illusion, whether the present moment is all that exists or whether past and future are equally real, and whether change is fundamental or derivative. Zeno's arrow hangs suspended in thought, motionless at every instant, yet undeniably in flight, a puzzle that refuses to vanish despite millennia of analysis, a reminder that even the most basic experiences, the flight of an arrow, the passing of time, the reality of motion, rest on assumptions that can be questioned, that beneath the surface of the obvious lies a tangle of conceptual difficulties that no amount of mathematics or physics has entirely smoothed away, and the arrow flies still, or perhaps it never moved at all, frozen forever in the paradox that bears its name.